Okay, is it full screen? Yeah, I think it's full screen. Should be okay. So, welcome everyone. I hope everyone's hearing me. If someone doesn't hear me, let me know, Anna, or if I'm not, if no one's able to hear me too. So, my name is Vlad. I am a master's student at the Vrije Universiteit, and this is my master project presentation. My project is called Limited Vocabulary Small Language Automatic Speech Recognition Using Machine Learning. I received academic support from my supervisor, Anna Sampaio-Bon, from Hans Ackermans, Andre Bart, and Francis Dito. And I worked together with W4RA and Bolesian. They helped me with this too. So I want to give you an overview of what this is. So it's an automatic speech recognition is a system that can listen to words being spoken and can interpret what those words are and give, as a result, the text of those words. I'm going to give you here some examples of use cases where such a system can be used. In our case, we have a software called Casa Daka, which is used for collecting information and providing knowledge for farmers in sub-Saharan Africa. And in that case, the software can be used for speaking and collecting information without having to use the keyboard of the phone and without having to use any written text. Another case was Philippines tuberculosis patients situation during the COVID pandemic, where a doctor needed to collect information remotely from patients, and this is another case where this software can be used. I did a lot of context and technical research, and throughout this research, I discovered that the environment in the use cases I mentioned before is a very low resource environment, meaning that software that we deploy there has to have very small hardware footprint. That includes the limited bandwidth internet connection, and devices that the software will be deployed on have low processing power and low storage. There are cultural differences, so oral communication is preferred over written communication. And in the technical research, I discovered that a good way to learn from audio recordings is to convert the audio to MEL spectrograms to represent audio data, and to use convolutional neural networks as the state of the art for speech recognition. In the data collection phase, I built a web application, which is now hosted at vocesraios.nl, and it uses a minimum overhead encode. It's written in bare-bone JavaScript, HTML, and CSS, and it takes only 410 kilobytes. It currently is able to collect the words yes and no in 16 different languages, which can be expanded to different vocabulary and different languages. And the audio files are sent that are collected are only 14 kilobytes, so they can be easily uploaded even on a 2G connection. Here's an example of how the homepage looks like. This is in the language Twi selected. And here, the blue button is how you can record the word yes in Twi. After this, followed the stage of data processing, where the audio files, first of all, had to be checked one by one for quality to make sure they're not noisy or that they don't contain the words at all. Then they were normalized so that the volume is the same, and standardized, their format was standardized so that they are all encoded in the same way. And then the audio signal was converted to a MEL spectrogram, as you can see in the example in my slides. Here you have a visualization of many random files in my data set. And as you can see, they are labeled yes and no, and each one looks very different from each other. And this is what the input will be to the machine learning model. I used this data to input it to the machine learning model. I used a convolutional neural network with 10 epochs, and I adapted the parameters to experiment with what gives the best results. And in my final results, I obtained an accuracy of 97 to 98% when using 2,000 samples of audio files, 92% for 400 samples and 90% accuracy for 200 samples. So already, even with a small amount of data, the accuracy has been very high in identifying what word has been said. For future work, my opinion is that the application can be expanded to collect and train more words for different languages and increase the vocabulary for those languages. The performance can be explored of other machine learning models that are available. Parameter tuning can be further explored. There's a lot of work that can be done there, and more languages can be added. And finally, the software can be made open source so that anyone who wants to build a not-for-profit automatic speech recognition is able to. I hope I'm within time. And this is my presentation. I try to do it as fast as possible because I have limited time, as I know.
Thank you, Vlad. That was very nice. It was very short and good. So thank you very much. And the floor is open for questions. Are there any questions? Justus.
Okay. A question. So this is quite impressive that you can learn from only 200 examples. Is your network particularly small, so you have few parameters to train, or do you use any form of data augmentation?
I used the data augmentation. So I took the files and I adjusted the pitch higher or lower, and I added artificial noise. So I created very different files from it in order to make sure the model doesn't overfit, and in order to make sure that it's also supporting situations where the noise levels are high, or different voices, for example, male voices, female voices, and so on and so forth.
The number 200 refers to the original examples, but the actual number of training examples with data augmentation is much higher.
For some reason, I cannot hear you very loud. I will try to.
Okay, let me ask again. So the 200 refers to the actual
now
number
I hear you better.
Still don't
Go
hear
ahead.
me? So the actual number of training examples of original training instances is 200, but the number that you use to train with after data augmentation is much higher.
Yes, it's much higher, but also what I've experimented with the 200 is that I took an even amount of augmented data, an even amount of non-augmented data, and created a sample of 200 files that can be used for training, validation, and testing. So as to see how that works. So I didn't only use the 200 initial samples that I were collected, but also I tried to make a very diverse array of 200 samples.
I have a question.
Thank you. Sure, go ahead.
Do you have a feeling how your system scales when you go to have more words than just yes and no? Like perhaps and definitely not, or help, or stop it, kind of that.
That's a good question. I've tried actually adding more words. I've actually tried adding digits from 0 to 9, and it has worked pretty well. I think the most important is whether the words are different from each other. So for example, if the word yes is similar to one of the digits from 0 to 9, then that can cause problems. So if 7, if the word for 7 is nes, and the word for yes is yes, then that can cause problems. So it is highly dependent on the language, but as long as these contrasts are high enough, you don't need a lot of data for this.
Okay, thank you.
You're welcome.
Okay, any more questions? If not, then we move to the next speaker, and that is Betul.